it like to be a bat? This is a question I think about often. Probably a bit more often than the average person. Now, to some of you, this question might seem a little bit familiar because it was made famous by the philosopher Thomas Nagel, who posed this question, what is it like to be a bat, as a way to challenge how we describe and study consciousness. Basically, his argument was that we will never be able to understand what it is like to be any animal because we don't have the ability to get inside that animal's brain and understand how it perceives its environment. Or, according to his logic, we will never be able to understand what it is like to be a bat. Now, for some of you, even just hearing the word bat might make you squirm. Bats are some of the most feared and, quite frankly, misunderstood creatures on our planet. But this fear that we have about bats is based on myths that simply aren't true, and instead reflect a lack of understanding we have about the lives of these remarkable animals. Professor Nagel chose a bat as his example for good reason. Bats live in a sensory world that is completely different and, quite frankly, alien than the sensory world that we are familiar with. But with my research, I aim to get inside these fascinating animals to try to understand how they are using their senses to navigate their complex world. I am an animal behaviorist and a bioacoustician, which means I use sound, the sound produced by animals, to understand their behavior and how those animals interact with their environment. Specifically, I study the biological sonar produced by dolphins and bats. So both of these animals can actually help us solve challenges we have with our own technological devices. This is a field of science known as biomimicry or bioinspiration. So consider this bat. When this bat uses its active sensing, it makes echolocation signals. To do so, it makes a sound within its larynx and then emits that sound out through its mouth into its environment, where it bounces off an object and returns back to the bat in the form of an echo. So these signals that these bats make, we call them ultrasonic because they're beyond our range of hearing. But if we are to take these calls and slow them down to 10% the original speed, we can hear what the calls of the bats sound like. So from that echo that comes back to the bat can then get information about its environment, make a map of its environment. From the echo, it can determine not only how far away an object is, but it can determine what distance the object is, and what direction it is, and what actually that object is. So, again, this is how these bats make the map of their environment. But with my research, I don't just study one bat, or 2 bats, or even 10 bats. I wear the hat for a reason. Lots of bats. I study hundreds and thousands of bats. What you are looking at is an emerging colony of Brazilian freetailed bats. These are a migratory species that spend their winters in Mexico and Central America and come up into the southwestern United States in the summers, where they form massive maternal colonies where the females get together and they give birth to the baby bats or the bat pups and raise the young. And when they come together in these groups, they form massive colonies of bats. And this is what I study with my research. I study how these massive groups of bats interact and all come together. The reason why is that when they form these groups, they're actually doing a task that really is quite complex for these animals. They're using their echolocation, all coming together, trying to get those echoes from one another without having any sort of interference in that environment. So to help you get an idea or an appreciation of just how challenging this would be for the bat, I'm now going to play for you a different sound. Instead of hearing one bat, we're going to hear what it would be like if you were a bat in the middle of this swarm. So hopefully you have a bit of an appreciation of just how challenging it would be if you were a bat trying to hear your own echo while you have all these other bats echolocating around you. And in fact, what these bats are doing, we think, is an impossible task. Everything that we know about biology, about math, about physics tells us that they shouldn't be able to use their echolocation inside these large groups. What should be happening is their sound should be interfering, it should be causing confusion of their sonar systems, and they should have a failure of their navigation systems. But the reality is, the bats are doing this very well, and they've been doing this very well for millions and millions of years. So what that tells us as humans is that we're missing something. There's something we still have to unlock about the secrets of these bats. And if we can figure that out, we can improve our own devices that we're beginning to use more and more every day. We as humans have been trying to emulate these animals for almost a century. We originally started studying dolphin and bat echolocation as a way to develop our naval sonar to help maintain the security of our waters. But as we're moving into a technological society, we're finding more and more active sensing techniques and more devices that we're beginning to use every single day. And despite all of the time and the effort and the money we've put into studying these animals and creating these devices, we still haven't been able to create a device that can do what the bats can do, that can use active sensing at the precision of that of a bat, and can use active sensing inside a large group with others without causing a complete failure of the navigation systems. So this is what I do with my research. I try to study the biological processes these animals are doing so that we can take that information and then apply that to technological devices. So how do I do this? How do I get inside a bat swarm and study the bats? Well, to help you have an appreciation for this, I invite you all to use your imagination and come along with me on a field trip to my field site. We're going into the middle of the desert in New Mexico. There, you will find a large lava tube cave where we have about 500,000 bats inside that cave. And so before we go into the cave, we have to suit up. So we have to put on, first of all, we have to put on a protective suit. This is for two reasons. One, we want to protect the bats from any pathogens we might be bringing in. And two, we want to protect us from any pathogens we might be getting from the bats. The second piece of equipment we have to put on is a full-face respirator. This also has two main functions. Number one, there's a toxic fungus that lives among the bat guano inside the cave. And if we were to inhale those spores, we would have a really bad respiratory infection. The second reason why we wear this respirator is that when you have 500,000 bats inside a cave, there's a lot of urination and a lot of defecation, and that causes a lot of ammonia to build up in the air. So if we didn't have our respirator, we may pass out within a few minutes of being inside the cave. Oh, and there's another piece of equipment we still have to put on, and those are our special rattlesnake boots, because we're in rattlesnake country, and rattlesnakes love to come inside the bat cave. Okay, so once we're geared up, we're ready to enter into the bat cave. So as you begin to leave behind the daylight, and as you go into the darkness, all you can see is what's illuminated with your headlamp. And as you start to descend into that darkness and take your first few steps, you'll notice that each step is a little bit springy. And as you continue walking, you'll notice you're suddenly going up a steep incline. What's below you is actually the guano of all of these bats overhead, and you're climbing a giant sand dune-like pile of guano to get into the cave. And if you keep going and you happen to look down at your rattlesnake boots, you'll notice that the ground is just writhing with movement. That's because there's a special beetle that lives inside the cave that feeds off of the guano. So there's millions of these beetles just moving around underneath your feet. Not only are they feeding off of the guano, but they're also feeding off of the baby bats that periodically fall from the cave ceiling. This is a maternal colony, remember? So we have a lot of baby bats that are being born, and periodically those bats will lose their grip and fall to the cave floor. Well, they can't get up and fly, but those beetles will start eating those baby bats alive and reduce them to a skeleton in a matter of hours. So once you keep walking, you'll start to notice that there's some movement off in the distance. And as that movement starts to come into view, you'll notice that what you're seeing is the vortex of bats that are flying around within the cave. Yes, these bats are nocturnal, but during the day, they're constantly adjusting their position throughout the cave. And so you have this complex flight behavior of these bats throughout the cave. So they maintain this vortexing as they fly around. And periodically, one of those bats might misjudge where it's flying because it's not used to a human coming into its world. And it might happen to land on your shoulder, so you take your gloved hand and you carefully pick it up and give it a little boost so it can continue along the way with the rest of its friends. And as you keep walking, into the cave, you'll start to notice this beautiful flight pattern that these bats are exhibiting, this very organized flight behavior of the bats. So at times, they almost seem to form freeway-like patterns within the cave based on where they are flying. And you can't help but just be absolutely wowed by this complexity of the bats. And you keep going, and you'll just see and be so appreciative of the beauty of this incredible bat ballet that's happening overhead. And you're absolutely transfixed by what you're seeing, even if you still have 500,000 bats that are urinating and defecating all over your head. So after hearing my description of the bat cave, you might be thinking to yourself, this lady is absolutely crazy. But let me assure you, I was never always this intrepid when it came to bats or bat caves. In fact, I wasn't even supposed to study bats. I got my PhD in Hawaii, studying dolphins. A far cry from a bat cave, let me assure you. And in fact, the first time I ever went into a bat cave, I was absolutely terrified. The first time I went in, I made it only about 50 feet before I nervously dropped my equipment and ran out of that cave as quickly as I could. But the next time I went back, I made it 50 feet further. And before I knew it, I was confidently climbing that guano pile and spending all this time inside the cave. And now I get to experience the extreme joy of taking my students there each new field season and helping to guide them into their bat cave journey. But by spending all this time with the bats, I'm beginning to unlock some of the secrets they have and start to understand what are some of the strategies they're using to be so successful with their sonar in these groups. So in addition to spending time inside the cave, I also spend a lot of time recording bats outside of the cave. And when I do that, I get to play with some really cool technology. So here is a picture of a drone that we developed in my lab. We use this drone. It has a special microphone on it to record the bats. And it also has a special camera that uses the body heat of the bats to make an image in the darkness. So we fly this when the bats are outside of the cave, when they're flying at speeds almost 100 kilometers an hour, to try to understand what adaptations these bats are using with their sonar and their flight when they're flying at high speeds without colliding with one another midair. Another one of my favorite technologies is our biological drone. This is our hawk. Her name is Belle. She is the newest member of our lab, and she is a female Harris hawk, and she's trained to carry a special backpack that we have outfitted with a special camera and a microphone. And she flies right through the group of the bats to get that recording from inside the group of the bats for us and get that data from inside the group. But with all of these methods, whether I'm inside the cave or outside of the cave, I'm fundamentally trying to answer the same question. What is it like to be a bat inside of a bat swarm? And with answering these questions, we can again begin to start to find solutions to problems that we have in our everyday lives. So as I mentioned at the beginning of my talk, at first, bats seem to live in a world that is alien from ours. But the reality is, our world is becoming more and more like that of a bat. As we're moving into this technological future, we're finding a greater need for active sensing devices. Active sensing is all around us. We use active sensing to defend our waters, to map the oceans, to find food. We even use it to create assistive devices for the blind. Even our robotic vacuums and driverless cars use forms of active sensing. So if we can begin to understand some of the secrets that these bats are using to be so successful with their sonar, we can better advance into our technological future. So even though most of you will probably never set foot in a real bat cave, we all have versions of bat caves in our own lives. These are scenarios that initially seem really scary to us, but are really just misunderstood. They seem scary to us because they force us to leave behind what is the familiar and instead head into the unknown. But if we can be brave enough to just take those first steps, we can gain the confidence we need to leave behind that world of the unknown and instead head into the world of dare-tos. So I encourage all of you to embrace the inner bat caves in your lives and dare to. Dare to leave behind what is familiar. Dare to boldly enter into the unknown and dare to navigate your complex world. Thank you.